I'm very happy for this last version of the seminar to have as a speaker Enzo Ferramnte. He has done a systems engineering degree in Argentina from the Unison University back in 2012. And then he did his PhD thesis in computer science in France at the Université Paris-Saclay with Professor Nikos Parachos and finished in 2016. And now he holds a permanent position as a researcher at the CONICET, the Research Institute for Signal System and Computational Intelligence in Santa Fe, Argentina, and is currently also a Fulbright visiting scholar at the Martino Center for Biomedical Imaging, or at least two.
It was. So, I just finished.
You just finished.
Just came back to Argentina a month ago. Yeah.
Yeah, but I was just there visiting. So we're so happy to have you here. We love to introduce us to that was published in the Proceedings of the National Academy of Sciences. So please go ahead.
Well, thank you very much for the invitation. I'm really happy to be here and to meet the community in Denmark. It's my first time visiting a group there, so it's really cool. Yeah, and so today I'll be talking about a paper that we published last year at PNAS. I will just put a small chronometer here, just to know, because I'm a disaster with time, and I don't want to go beyond 30-40 minutes, as we say. So yes, let me see if this works. Yep. So just for introduction, this is the group of people with whom I'm working here in Argentina, some of my PhD students and collaborators. And today I'll be discussing some works, especially the paper I'm presenting. It is a work that we did in collaboration with Diego Milone, Nicolas Nieto, but I'm also highlighting here Rodrigo and Agustina, who are also other team members who are working on these topics of fairness and machine learning. And this is our university here in Argentina. Just in case at some point you can visit, you can see a very green city surrounded by rivers. So yeah, that's what we are. And this is the university. Cool. So for today's talk, I wanted to start kind of telling you how we got into this topic before going into the paper, because I think that's so I wanted to mention a few works before going into our paper. A couple of years ago, we saw this fantastic article by Londa Shivinger from Stanford University that you may be pretty popular article. The title is AI Can Be Sexist and Racist. It's time to make it fair. And when I read that and I realized that I was creating models based on AI, particularly on deep learning, I say, okay, I need to start analyzing what's going on with my own models. And so this article introduced a lot of different examples in different application domains of AI. And this is a screenshot I took from my own phone 3 years ago or 2 years ago, when we have this text written in Spanish. Maybe some of you are speaking Spanish, I don't know. But here it says, ella es una investigadora, también escribe libros, which means she is a researcher. She also writes books, but somehow this translator thought that if somebody is writing books, it should be a he. And that's, as we know nowadays, this is some kind of bias which was incorporated in these algorithms when they were learning from data that is basically replicating some kind of gender stereotype we have in our society. And this was one of the examples. Then we also have this paper, which was really, I think, foundational in these topics by Bolunami and Timnit Gebru, where they basically show that many of the facial recognition systems that were commercially being used had a really different performance for dark females. So they made basically, they audited these models considering gender and skin color, and they observed that for dark female people was much higher than for other cases like dark male or even light female, etc. So these are some examples that kind of motivated us to start thinking about what's going on with AI algorithms in medical imaging. That is my domain of application. And this is a really interesting sentence that is written there in Londa Shivinger's paper when she says, biases in the data often reflect deep and hidden imbalances in institutional infrastructures and social power relation. And I think the way these databases are constructed, especially since most of the images that we usually, or images, text, or whatever that we usually use when we that are used to train our models, are captured in the North Hemisphere, reflecting, of course, and in the Western world, reflecting some kind of bias, of course, in the sense that these societies works, which is not the same that the global South work, for example. And the fact that these algorithms are learning from this data, well, it makes them kind of replicate this behavior. Researcher, well, I really got interested in these topics and started to ask questions. Many more articles from Londa, particularly, that is the line of literature I was following, which was about these gendered innovations. She's one of the ones that started to talk about that many, many years ago. And if you have not seen this paper, I think this is really interesting because it goes beyond AI and it talks about how important it is to incorporate sex and gender analysis dimension, not only in AI, but also in any type. So, as I was telling you, see these papers about bias in AI, fairness studies, these other papers about gender innovations, and then, I mean, I'm coming from the MICAI community. I've been always doing medical image computing, and particularly using learning. How we came to this work that we are going to discuss today, where we basically analyzed gender imbalance in medical imaging data sets and how these can impact the performance of classifiers in different subgroups, subpopulations. In this case, considering gender as the protected attribute, but well, of course, we could consider other type of protected attributes we will discuss today. And this work was really well received, I think, in general by the community. We are really happy with this work. It was even, we received some prizes from Mercosur, which is kind of the European Union of the Latin America. We really interesting portals like Stat News, etc. And this is the question then that the impact of gender unbalanced data sets in deep learning models for medical image classification. So now going into the paper, this is the experimental setting that we will have. We have images, in this case, X-ray images, and we have convolutional neural networks models, which can output a score associated to different pathologies. And the idea, of course, is that we want to train this model to tell us how likely is a person of having hernia, fibrosis, edema, whatever. 12 different categories, depending on the data set that we use. And we are in a multi-label setting here. It could be that, for example, the classifier assigns 1 to hernia and 1 to edema at the same time, because we are considering that the person could have two or three or whatever. And in general, in the community, at least until a couple of years ago, whenever we were talking about unbalanced data sets, we were talking about unbalance in the sense of the target class. So basically, how many positive cases and how many negative cases we have if we are in a binary problem classification. Balance would be related to the different pathologies. We have a lot of cardiomegaly images, for example, but less images of hernia or whatever. But in our work, we focused on a different type of imbalance, that is in the sense of protected attributes. So protected attributes are, in general, demographic attributes or attributes about the population that we are studying that in general we don't want our model to look at. And these can be, for example, gender, sex, it could be age, it could be ethnicity. And this is the type of imbalance that we tackle in our paper. There was this work, I think Veronica Chepilgina was also giving a talk here at this seminar, because I look at the website. And she came out with this paper also a couple of years ago, which is really interesting. And they did this study, which also kind of, I mean, we saw it after we submitted our work, but kind of motivates or somehow supports the kind of claims we are doing here. In her work, they analyzed the proceedings of MICA 2018, looking for papers working on diagnosis using macroscopic images as X-ray, for example. They found that there were 65 papers there, and that only 12 papers describe at least age or sex, so of the population that they were using for analyzing. So these papers, basically what this study is showing is that from 65 papers in the proceedings, only 12 were describing the demographics of the data, of the images we are using. And of these 12 papers, only 3 were also evaluating or discussing their results with respect to the demographics. So this shows that basically analyzing or auditing our models in terms of the performance of different subpopulations is not a common practice in our community, or at least it wasn't until 2018. And what we wanted to show with our paper, with the paper that I'll be discussing now, is this is not happening, but we may be having really disparate performance on our model. So this kind of, yeah, it was really useful to see this as confirming somehow our intuition that this was happening in the community. So this is a really good paper. I recommend you to go and check there. And so, what's the experimental setting that we use in our PNAS paper? Well, we use 2 different data sets, which are really famous and really well used in the community. One is the NIH data set, where we have about 100,000 images. It's well balanced, I would say, in terms of male and female patient images. And same for the other data set that we will use in this experiment, that is the CheckSpert data set. From which we used only the frontal views. It has much more images, and well, it has also uncertainty label that we consider as negative labels. Implementation detail, I would say in this case. So we have these 2 data sets, lots of images with different pathologies annotated in every image, and we can say that they are kind of well balanced. So this will be useful for us. We also evaluated or did our experiments considering 3 different architectures to be sure that the conclusions that we are getting are agnostic to the backbone architecture that you are using to perform these predictions. We used 3 of the classical ones: DenseNet, ResNet, and Inception B-tree. And these are the scenarios we analyzed in the paper. So we had a scenario that we call full imbalance, that is basically training only with male or only with female patients, and then testing separately on male and females. And then we had partial cases where we created this gradient of imbalances, where we had like 25% and 75% of female and male patients, 50-50, and then also the opposite of that. And then we also tested on male and female patients. And so we repeated these experiments 20 times with different training and test folds to observe the trends, because we wanted to filter out the noise that may come because of the training procedures. We constructed these folds, the folds that were used for training, so that for every pathology, we have the same number of male and female patients. And then we measured the area under the ROC curve for every model using the different estimates. So this is the experimental setting. Basically, we have only the male images, we train a model, and we call direct prediction to basically predicting on patients of the same gender, and then also cross prediction where we are predicting on female in this case. And then we do the same, we train with female and predict on both. Things we observed. So this is for one pathology, for example, pneumothorax. And we are seeing that when training with male images, and testing on female images, well, performance on male is lower. And this may be by chance or whatever, but when we start analyzing all the different pathologies, we start observing this trend all over there. In some cases, differences are not significant, like not really, really significant, like here. But in general, you can see this trend. And this is, I think, the important conclusion here. And sometimes it's even not that big, the gap. But in any case, the trend is there. And we confirm the same in both directions, like when training with male and testing on female, and the opposite also. And we also did that, as I was telling you, for 2 different data sets. So these results were on NIH, but we did it on NIH using DenseNet, on NIH, on Chexpert with the DenseNet. And again, you can see the same behavior. We did it with ResNet on NIH, with ResNet of Chexpert. Well, all these results are not in the paper actually, because it was a brief report, so we couldn't include them there, but we put them on the website, and so they are also available as kind of extra material. And same for inception victory. And one may wonder, why is this happening? And so this is some study that we did afterwards that we didn't publish. Finally, this is something that we were doing to understand what's going on. And here is, I'm showing the class activation maps. So, you know, basically class activation maps are somehow telling us what's the zone of the image, the area of the image that the network is looking at to tell the prediction is telling, right? And some class activation maps generated for, when training a model with male images and then testing on female patients. And we took particular situations. So basically cases where they were saying, this person has a lung opacity. And this looking at the breasts and saying, yeah, this person has a lung opacity. And this was kind of, I mean, of course, here, these are some cases where this is really clear. In some cases was not as clear as in this one, as in these cases, but in general, this was a trend that we observed. And this, in order to observe these, we trained a different model only for lung opacity. So it was a binary problem here. It was only, we kind of used different pathology labels in a single one, that is lung opacity, where you can have different pathologies under this label, to simplify the problem and try to filter any interference that was coming. But this is what we observed. And this is a really old paper from 1958, where you can see that at that time, they were already reporting that the female breast is a common source of confusion in the interpretation of chest X-rays. And the network, when we train it only using male images, well, did not learn features associated to how can I extract the lung opacity in a female patient that has breasts. So this is the kind of explanation. This is kind of an explanation for what we are seeing. And you also saw that in your paper. and I really enjoyed reading this paper, especially the last part where you give kind of different directions or recommendations. And you were also saying that actually you observed more things than what we observed in our own results here, when you were saying that some of the pathologies are more difficult to be predicted on female patients than on male patients. So now I think I will finish pretty early actually, because I went fast. So it would be nice to discuss about this, what you observed there. I would be really happy to listen to your comments. But then we also did a different study that was the partial imbalance study. And what we did, it was to train models with different proportions of male and female patients. And here you can see, for example, a model that was trained with 75% of male images and 25% of female images, 50-50, and also 25 and 75 in the opposite direction. An important thing with this study is that we kept fixed the number of total patients we are using for training, right? When we, I mean, the number of training images was the same. We just changed the images in proportions. And we analyzed again what happens with the performance of these models in terms of AOC. And this is what happened in the extreme cases, but when you go to the kind of this gradient of imbalances, here we are seeing, for example, what's going on when testing on male images for two different pathologies, atelectasis and pneumothorax, which were two pathologies that had significant differences. And what you can see, remember here we are testing on male patients, and this is the percentage of female patients we used in the training data set. So, wait, female, 100%, so I think it's the opposite here, right? I'm always having the same problem. So when using 0%, no, this is okay, 0% of female images, so it's 100% male images, we are getting higher accuracy, higher AUC. And when we start increasing the percentage of female patients, this goes down. But an interesting conclusion for this study, or at least observation, is that look at what's going on when we use 50-50 and when we use 0% of female images in these cases. There is no difference in performance when talking about male at testing. So this is somehow telling us that the information that we are adding by adding male patients, when we are testing on male patients, has kind of a plateau on how much you can gain from that. And at some point, it's even the same or better adding female images, even though you are not going to use these classifiers on female patients, but this gives more diversity to your data set. And if you then compute the accuracy of these models for the whole population, you will see that this for the whole population is getting the best result. This is related to the value of the data and the diversity of the data. So this is a study we are now replicating on different settings with not only medical images, but other type of setting, and trying to measure the value of diversity in data. I hope we will have something more to comment on this topic soon, because it's some work that is also going on. Yeah, so this is what we were seeing, and you can see the same when you change the direction of the imbalances. But so somebody could then ask, okay, should I train a classifier per gender? Is that the best thing I can do? To be honest, I wouldn't like to ask a person, what's your gender, what's your sex, before using a classifier, because what will we do with transgender people? What do we do with, I don't know, non-binary people? It's really not a nice way to go, to me, in these cases. And so we did the following experiment and say, okay, now let's say I have these 100 images of male and 100 images of female patients. And instead of doing 50-50 as I was doing before, I will train a classifier only using the 100 male images. But then I will also train another classifier using all of them, 100 male and 100 female patients. So I'm going to 200. I'm increasing now the number of images, differently from what I was doing before. But if the data is there, you can use it. I mean, or you go and train one classifier for female and one classifier for male using 100 images for every one of them, or you train one for both of them using all the images. And what we observed is that when using all the images, even though what I'm adding is female images here, it increases the overall accuracy or AUC of the model in general for all pathologies. And the same happened in the opposite direction as well. This is not in the paper needed. This is some experiment that we did afterwards. So again here, I think it's an discussion that if you have the data, well, just and the more diverse your database is, the best performance you may get. And this goes in the same direction with the comments I was telling you before. So from here, some takeaways. Well, the performance of these CAD systems we believe, and I think you also believe, because it's what you put in the paper, should be audited at the group level also, considering demographics like sex, gender, or age, or different things. Here, there is something important that I would like to mention. In the paper, we use the term gender, although, and we also put kind of the disclaimer in this case, we believe that the term should have been sex, that we use here, because sex and gender is not the same thing. And here we are more talking about anatomical differences, which may be more related to sex assigned at birth. But in the databases, in the NIH database, that is the one that we use at the beginning of our study, the label was gender. So we didn't want to override this with something that we believe. We took that. But yeah, this is just a kind of a disclaimer that I want to do, because we know that gender and sex are not the same thing, and gender is much more related to cultural things and self-perception than sex. Also, another takeaway that we observe here is that, of course, CNNs, and we know that, are prone to learn features useful for specific subgroups seen during training. And if we do some kind of domain shift, that is basically what's going on when we go from male to female, well, this may lead to a decrease in performance, even though we maybe wouldn't think about that. I mean, there are other cases now where they are, for example, showing that you can estimate with a really good performance the sex of a person looking at a retinal image from that person. And that's something you wouldn't think you can do, or at least it's not obvious. But if you can do that, it means that they use some of these specific features to predict something. And if you only train with retinal images of male, it may happen that the performance on females is not as good. We didn't do that study. This is something we wanted to do, but we couldn't find the databases with the demographic information ready to use. But yeah, this is an interesting takeaway, I think. And so authors should report the demographic information together with the medical image computing papers, and especially with public data sets. For example, when we did this work, we also wanted to use the MIMIC data set, which is another one, similar to Chexpert. And at that time, there was only MIMIC 3, I think. And we contacted them and we asked them, do you have the demographic information in terms of sex? And they say, not in this version, we are going to release it in the 4th. And then they did in the number 4, I think, MIMIC paper for the images. But well, it was already late for our paper because the paper was already published. But I think it's a practice that the community is starting to use. That is a practice that is really common, really normal to do that in biology, for example, or in medicine. You always report that, but we don't in MICAI or this kind of computer vision communities also. So it's something we need to think about. And so a really important takeaway from that is that diversifying your data set is really important for training your models, even though sometimes you are adding some diversity that you are not expecting to see at test time. But even that diversity can help. But this is not enough. And this is a really interesting talk by Rachel Thomas last year at the AMI Symposium in Stanford, where she discussed, well, why diversifying your data set is important, but not enough. And I recommend to watch this talk. And also, I always like to, I mean, why is it's not enough? Well, because we also need to diversify other things. We also need to diversify our teams, for example. We need people who can realize about biases. And this is really nicely reflected in this documentary, Coded Bias. I don't know if you watched this, but this is a really good one. I think now it's available on Netflix, where Bulumnuami, one of the authors of the facial recognition paper, realized that a facial recognition system was not working because it was not working on her own face because she's Black. And when she put this white mask, it was working, and then it was taken out and it wasn't working. So it took herself to put into the system and see how it wasn't working. And so we need to have Black people in the teams that diversify in that sense, right? Like they can also realize about these things. We need to have Latin people. We need to have, well, I mean, in this kind of sense, diversifying. And this is kind of reflected in this sentence by Timnit Gebru, which is really nice and says a lot of times people are talking about bias in the sense of equalizes performance across groups. That is basically what we are doing here. But they are not thinking about the underlying foundation, whether the task should exist in the first place, who creates it, who will deploy it, on which population, who owns the data, and how it is used. So there are many more questions that we need to start asking. Of course, me as a machine learning person, I will in particular look at some point, but we also need to amplify that. And unfortunately, the MICAI community is starting looking at these problems. So there was this interesting paper by people at IBM in MICAI 2020 about fairness of classifier in different skin tones in dermatology. This year, we had a really interesting paper by Esther Puyol and Andy King from King's College, where they analyzed fairness in segmentation tasks. This is the first paper that analyzes fairness, to my knowledge at least, in segmentation tasks. So it's nice to see that the community is starting to look at this. I believe we need to have kind of a forum or something like what you are doing now, but even wider, maybe, I don't know, a MICAI workshop or something like that, or a standalone workshop or some forum that allows us to go together, the medical imaging people, and discuss these things. So we are actually thinking on maybe organizing something like that for next MICAI, and of course you are more than invited to join if you think something like that would make sense, or maybe something standalone, non-MICAI workshop. Well, it depends. And yeah, we are also now starting other research lines, like for example, working with skin lesion classifiers with some of my colleagues here, Rodrigo and Agustina. Agustina is working in a hospital. She's doing her PhD in a hospital. And here in Argentina, where our population has really diverse skin tones, and they are working on the development of tools that help to diagnose this kind of skin cancer. And yeah, we are starting to analyze whether these fairness studies are important here or not. What can we do? How can we improve these results? So this is something pretty new she's doing now. And also there's another line of research who is tangent, I mean, it's pretty related to this, that is basically how are we evaluating the performance of our classifiers? And this is basically a critique to our own paper, because we observe that the community is using AUC to evaluate these things, but basically AUC is not good when you have really high imbalance, as you have in terms of the target label here, I'm talking now, as we have in these X-Ray data sets. So we are basically showing that the community practices are not really reflecting the performance of this classifier. We are sometimes really over-optimistic, and this is some work that is we have now submitted to a journal, and we expect it will be out soon. So yeah, at the end, I took only half an hour, so it was okay. I kind of rushed through many of these things. So thank you very much, muchas gracias, and yeah, I'm open for questions.
Thank you so much. That was awesome, Enzo. Thank you so much. So I will, what do you say, act as moderator. So if someone wants to ask a question, please just raise your hand. You can do that in the reactions. You just push the raise hand button, and then I'll call on you and you can ask your questions. If you do not want to say it out loud, you can also write it in the chat, and I will monitor it. And unless I have someone that wants to ask it, there's already Sune has his hand up, so I'll give the word to Sune to ask the first question.
Thank you, Enzo, for a really interesting talk here, and I think also for raising this issue in general. So the first thing I think is really a great insight here is that there seems to be, I mean, I'm a philosopher my background is in philosophy, so it's relatively new to me to enter the machine learning community, in particular the medical imaging community. And I have to admit, from the outside, being a moral philosopher, it's sort of striking that apparently it isn't standard to consider these demographic features in terms of the performance of classifiers. So I think this is a really important topic, especially given the importance of the work that you're doing. One thing that I'm wondering about is in Denmark, and I guess in the EU, and at least in general, there's a lot of debate about privacy with respect to health data. And if you look at the sort of regulations that are now in place in the EU, there is sort of an idea that each individual person should, in some sense at least, be in control of the use of their own health data, let's say. At least you need to somehow give consent to the use of these data for things that they weren't expected to be used for when you sort of accepted them being recorded. So the reason why I'm asking, what I want to ask you about is, it seems to me that there must be some sort of conflict between the idea that each individual is in charge of determining who should use their personal data or health data, and then the importance of ensuring representative data for the training of these sorts of systems. Because you might, for instance, I suspect, have certain groups, which are for some reason or other much less represented in the data than others. And this might not just be now because of historical issues. It might actually also be the case right now when data are recorded in all sorts of exchanges, that certain populations are just less represented in the data in general, whether it's online or in some other respect. They might visit healthcare providers less and so on. So I'm just wondering, and this is the question, do you see this as a challenge, or do you think that that's not the main challenge for ensuring more equity in the training data and so on? And if it's a challenge, what do you think could be done about it from on behalf of people like yourself who are actually just trying to make good classifiers, and you're not politicians or anything?
Yeah, so I do believe, and this we have discussed a lot, that this is kind of a trade-off that you have between privacy and the data being there for us to use. And because, yeah, I mean, here we are asking to incorporate for every image some demographic attributes that were not there before. So this is reducing the privacy of the data, right? If you have only, for example, aggregated demographics and you say 50% of the population, and this is not as it's not violate how privacy as much as putting these data associated to it. At the same time, if we want to offer system, this is of course a trade-off. I think one of the solutions there is to ask, and it's basically what we do, to ask the people whether data or not, and basically have volunteers who want to provide the data, they don't have any problem with that, and then you sign an agreement where you say, I'm giving my data, but this is made volunteer. This may be one of the directions, and I think in general you need to have a consent from the person to use the data. Otherwise, you need to waive it through some ethics committee or something like that, which is not the these big databases are constructed. I mean, I know how they are constructed in the sense that they are or NIH data set, they analyze the electronic health records and they extract the labels from there automatically using some natural language processing algorithms. But I don't know what's going on with the consent of that people. I don't know if that people signed something. I guess they had signed something. I really don't know how it works. So this is like make volunteer, basically, could be one of the directions in which we can conciliate both worlds. And then you were also, and I forgot because I have short memory.
I think it's about how do you think we could ensure good representation, that we get more diverse data as engineers who just wants to use the data.
Oh, yeah, how we encourage data diversity. Well, this is also a good question because, I'm not sure. For me, for example, is working from here, what I'm trying to do, like from the south, trying to create our own data sets, and which reflect the reality of our own population, which is not always the same that the one in the north. So this is one of the ways, basically pushing our researchers in the global south to create their own data sets and kind of, this is one of the ways. Supporting that, because sometimes we don't have the resources to do that. I mean, in some countries more than in others, you need money to do these things. You need to pay people to collect the data and to curate it and to pre-process well. So yeah, I guess this is one of the directions, supporting these kind of initiatives from the south, which is happening with some organizations. I'm, for example, working now on a project here in Argentina, which is fully DRC, which is a Canadian organization, and is related to how can we implement electronic health records along the whole country, because structure for that yet, and the country is developing it, like we are developing as a country an electronic health record system, and basically this will result in collecting data. And we are also thinking about the strategies on how we can incorporate their AI to increase the things that the electronic health records can do. And for that, we are funded by external sources also. Of course, the state is also putting a lot of money on that. And I'm particularly involved in this project because we are trying to, whatever we create there, to be fair, basically. So I'm trying to audit these models, and there is something really interesting there that I think connects well with your question, that came out in these discussions, that is, how do we represent these protected attributes in our databases? Because it's not straightforward. When you want to ask gender to a person, gender is not a binary label that you can put male or female. This is a fluid concept. There are many, many different genders, gender identities. And how do you represent that in a database? How do you make it a data that then you can analyze? It's not straightforward. We are actually doing research about that. There is a really interesting paper about Shakir Mohammed from DeepMind on that sense, where he discusses with other researchers how basically these AI technologies are impacting queer people. And one of the problems that you have when dealing with queer people data is that some attributes are not matching the standard definitions that we have usually used. And this is another challenge, I think, for us, how to represent our population in a fair way.
And there's actually something related to that now, a question by Martin Rusek in the chat, which is then, if you have an unbalanced data set, would you suggest balancing it via weighing or deleting images, or would you actually rather keep the original imbalance and then note the limitations that come with it? What would be your procedure be if you have to make do with what you have?
Yeah, I see. Well, that's also, I'm not sure I have an answer for that, because, I mean, I would say maybe balance it using some kind of reweighting sampling or something like that. Do not throw away data, because we are seeing that basically having more data and more diverse data is good. What I have seen in many of the papers that are coming out about how to mitigate bias from an algorithmic point of view is that at the end of the day, you end up reducing the disparity, but you end up making all of them worse. So yeah, we have a classifier that has zero performance for everybody. Yay. This is not better than having a classifier that is 50% for 50 out for one population and 70 for other. So we need to think about ways which are improving fairness, but not reducing overall performance. And resampling could be an alternative. I mean, there are many ways in which you can deal with this. There is a nice article now by Gael Barocqua in Giga Science, which talks about these things, how reweighting sampling relates to unbalanced data sets. Maybe this is a good pointer to look at. But yeah, this is an open question to me. I can't give an answer.
Yeah, it's very interesting. And then Eike has another question in chat that is like, one thing you observe is that there are important differences between groups such as males and females. So would it be reasonable to include such group variables, biological sex, ethnicity, as inputs in the classifier, in your X-ray classifier, for example?
Yeah, this is again another question that is open to me. And when I was reading many of the Londa Schillinger articles, she's basically talking about the importance of analyzing male and female, considering that direction of analysis. When you are doing, for example, I don't know, testing a drug or something like that, testing it in both populations. So from that point of view, it's important to see, I mean, to consider these differences. Now, I wouldn't like to ask a person, what's your sex or what's your gender before. So, and also, I think it's different when we talk about images than when we talk about other data modalities. Why? For example, if we are looking for a nodule, a lung nodule, the lung nodule is something that we can see in the image. And even though the features that we may need to detect it are different in male and females because of the breast that we were seeing, the node is there. And so we can say there is a node or there is no node based on the information that is on the image. And we shouldn't need to know whether this is a female or male patient to say that. So if we humans do not need to see that, I guess a classifier shouldn't neither. There are other cases, and here also enters the priors basically enter into, when you look at it from a Bayesian perspective, there are certain pathologies who are prevalent on males and female, or of course, there are pathologies that can happen on female, cannot happen in male, or vice versa. And so whether to use this prior knowledge or not, it's a really, I don't know, tricky question, because it may help to improve the performance of the classifier, but at the expense of what? So, yeah, I don't have answers. I only have questions.
Cool. And then Sune had another question following that.
Yes, sorry, Enzo, because I'm slightly ignorant about this, the sort of machine learning aspect here. So I'm going to ask you some more general questions probably, but I can't help wondering. Well, first of all, I think there is an interesting issue that you point to about this feeling that it's not so good if we have to go down on performance in order to become more, to ensure some sort of equality that we find desirable for moral reasons or whatever. I think this is an issue that is highly relevant to consider in general as an issue about what fairness consists in and how it relates to utility and performance as usually understood. It's a standard moral issue that you might right thing just by maximizing utility. So I think maybe there needs to be some sort of way of calculating the value of fairness in terms of some sort of on a scale that can be that might make it add to the utility, so to speak, right? Or the value of the performance. So that's one thing that maybe you have some ideas about that. And the second thing I just want to throw out, I know this is the sort of naive question, but about different statistical fairness criteria. And as I understand it, AUC is sort of based on sensitivity and specificity, or error rate ratio.
Yeah,
but some people would argue, and I think in particular philosophers tend to argue at the moment that that's not really morally relevant. What you want to look at is whether you have, and this is again just whether the system is, the algorithm is calibrated across. I'm just curious what your view is on that sort of, if you have any view on that debate. So.
I say precision on recall. This is actually the other AUC that we are proposing as a better indicator for imbalance. But yeah, I mean, I think both questions fairness. What do we think fairness is? I mean, we need to give, as you of fairness in the statistical sense, which sometimes actually they are mutually exclusive. So you cannot maximize both at the same time, as this has been shown by many in the so I think it's related to the application that you are thinking, and you have to wake that there. And this is another reason why having diverse teams is important, because at the end we incorporate somehow just by taking a definition of fairness, and that definition, well, it's a person who is taking the decision optimized. And so we need to agree on a common concept. I mean, yeah, I don't know. It's again, sorry for not having any answer here. But
I'm just curious about your thoughts. I don't think there is a clear answer to this, but I think it's people from different backgrounds sort of just telling what they think about this.
Yeah, actually, I wrote an article in Spanish that, of course, is not useful here, but about this, like a kind of a public communication of science article about gender, bias and AI. And many people from the social sciences came after that and commented on the importance of starting discussion with us. Now I'm going to different social sciences conferences and discussing these things with people. This is really interesting for me, coming from a pure computational background, right? Yeah, so having a philosopher here in the table, I think it's amazing. Yeah, that's what I can say.
Thanks, Enzo. Thanks a lot.
Yeah, and then maybe I'll be allowed to ask the last question for now before we wrap up. And there, I wanted to go back to this medical applications that you guys were also in it a little bit now. So, like you already mentioned, a lot of times the more machine learning, pure machine learning approaches, well, let's just make sure that we get a fair classifier so performance is equal for both. Whereas, for example, the issue of heart attacks, for example, then as you already said, the biases, I mean, are also working for the doctors. If a patient comes in with chest pain and is of a certain shape or gender, the doctor will more likely say, oh, I think you have a heart attack and I will treat you thereafter. Sometimes in the favor of the patients, sometimes actually they don't, because, for example, in women, heart diseases are often undetected because the stereotype is it's the man that has a heart attack. And my question is, do you think there would be a problem in those cases where really the distributions of the data are so different that merging them actually makes both of them actually develop things that are gendered? Or do you, because you mentioned before you would rather not like to use the gender, but I guess there would be clinical situation where the gender gives you so much information, it would be for the individual patient better to ask them for their gender because they would have 10% better chance of getting the right treatment. What do you think about that?
Yeah, I think there, and this is, I mean, during the last year, I've been working a lot on this program. I was telling you about representing people on databases, particularly transgender people. And in these cases, one of the things we have seen is that gender or sex maybe sometimes are not really the important things that you should ask. Sometimes it's a specific organ. So you don't need to ask a person what's your gender. Maybe you need to know that that person has that specific organ. And so, and I'm saying that because I've seen how transgender people suffer a lot from having to be put in beings that are created for the heteronormative world. And so that's why we need to find a compromise between using the prior knowledge that we have about the prevalences. Of course, this is something that is there. We cannot say this is not there. We can use that, but also how to treat people, how to relate with people in a way that is not harmful to them, and that doesn't make them feel bad. Because when a transgender person goes into a hospital, and we were looking at the first version we had of the electronic health record in our country, and it had a binary field, for example. And we say, no, this cannot be like that. You need to give the people the opportunity to say that they are something else. And so these kind of things is like you have to wake them. Of course, I think that there is scientific evidence about these differences that needs to be taken into account when doing the predictions. But what I'm saying is that we can do that, but also being careful with the way we treat people, because at the end, it's people that we are dealing with when we are talking about medical stuff, right? So yeah, but it's, again, there is no answer.
Yeah, no, but exactly, there's a lot of things to think about. And for example, often I guess in a lot of medical purposes, exactly like you say, what we're actually not after when we ask for gender or sex is your sex. It's actually from your sex, I infer your hormone levels are like this, and therefore you have higher blood pressure, and therefore you have more risk. So it's a whole construct. So if we could be more specific,
yeah,
what do we actually want to get?
Exactly, because sometimes it's not the gender, it's not the sex, it's not even the age, it's the activities that you do sometimes who are exposing you more or less to factors of potential diseases. So yeah, so maybe we need to go more, it's much more work, because we need to really scratch I mean, go beyond the things that we are thinking now. But well, it's worth thinking about it.
Cool. Thank you so much, Enzo, for coming. Thanks everyone else for coming. It's a little bit too far now, so I'll let everyone go. Everyone says here, Julia Aman also says, great talk. Thank you, Enzo. We are very, very happy that you had time to join us. I know it's morning for you now, and it's late afternoon here in Europe. And I think all of us from our project here, Eike, the postdoc working on it, but also Sune, Osa, and me are super interested to work with you on either organizing a workshop or you know, working together, because we're looking in those directions as well. Veronica is now also in Denmark and is also interested in collaborations. So we feel all like very like you strongly about we need to do things to make this
totally
more visible.
Yeah, I would love to continue these discussions or think about projects together wherever. Actually, one of the first authors of this paper is now in the job market looking for postdocs. So if you know about positions,
good to know. Yes.
So Nicolas Nieto, one of the first authors, because it's a joint first author paper, is there. So if you know about positions or people, well, I mean, it would be also nice to maybe a good way of collaborating. So yeah, we are open for everything, and I hope to see you again soon.
Yes, definitely. I think so. Then again, thank you so much, and then everyone have a nice morning or afternoon, and when you get that far, a nice weekend.
Thank you.